Hi, hello, welcome to Homeschool. This is your Class 8 Mathematics NCERT or CBSE board. NCERT syllabus followed by State board and CBSE board. Both are having same content. There is only one tiny difference, that is your textbook cover page and chapter number it differs. Today I am going to start rational numbers. This is a chapter 2 in Karnataka State board and chapter 1 in CBSE board. Before starting this chapter, we need a tiny basics. Rational numbers. Before knowing about rational numbers, we should know other numbers. So I have already done in mathematics basics, which is provided in the description box. You can go to the mathematics basics, and if you need any of the basics of mathematics, you can search in it. In real numbers video, I have provided you what are all the basics needed for your numbers. Please check that video. That video, complete folder of mathematics basics will be given in the description box. You can press that link and you can go through any of the basics you need in mathematics. 1, 2, 3, 4, 5. What am I doing? I am counting. Counting fingers by what I am counting? With numbers. These numbers are called as counting numbers, and these counting numbers are also called as natural numbers. Natural numbers. Counting numbers are called as the natural numbers and is represented by the letter capital N. We write the set of natural numbers with a flower bracket. 1, 2, 3, 4, so on are called as the natural numbers. There is no end for these numbers. Let me take a circle here and let us write capital N indicates natural numbers. 1, 2, 3, 4, 5, so on. You can write many numbers. This circle shows some of the natural numbers. Natural numbers is represented by the letter capital N. Next, suppose if I join 0 for this counting numbers or natural numbers, what are these type of numbers called as? Whole numbers. What are these? Whole numbers, and they are represented by the letter capital W. Okay, and now let me take one more round and capital W here. Natural numbers along with 0 are called as whole numbers. Already you can see natural number circle, so extra you need 0. So what I can say here, natural numbers are subsets of whole numbers. Natural numbers are subsets of whole numbers. Whole numbers contain natural numbers. So this is a part of whole numbers. Yes or no? This is a part of whole number circle. Next type of numbers, natural numbers along with 0 whole numbers, extra -1, -2, -3, so on. Say here, natural numbers, whole numbers, negative numbers combinedly called as, what is this? You are all well known about these numbers. You have one complete chapter in your previous class, that is integers, right? Integers. What are integers? Whole numbers and negative numbers are called as integers. Or 0, positive numbers and negative numbers are called as integers. Let us take one more round here. Okay. This round indicates integers. Integers are represented by the letter I or Z. So let me take here capital Z. So in integers, natural numbers will be there, whole numbers will be there, and extra what do you have in integers? Negative numbers. Negative numbers are extra. Integers contain 0, positive numbers and negative numbers. That means natural number is a subset of whole numbers. This is subset symbol. And whole numbers are subsets of integers. You can see a big circle now. That is integer circle. In integers, you have these are all subsets. These other numbers are all small parts in this integers. Okay. So what are next type of numbers? Look here. Counting numbers. Whole numbers. Right. Along with zero, whole numbers. Along with negative numbers. See here. Counting numbers, whole numbers, integers, and you can take 3 by 2, 7 by 5 or 7.5. What are all these called as? These are all called as rational numbers. All will come under rational numbers. Rational numbers are represented by the letter capital Q. The numbers which can be expressed in P by Q form and Q is not equal to 0, these numbers are called as a rational numbers. It will be having a numerator and a denominator, and the denominator is not equal to 0. If equal to 0, what happens? Let us say P by 0. Then P by 0 is not defined. Denominator will never be 0. If it is 0, then it is not a rational number. You may get a doubt. What is that? 7.5 decimal. Decimal you can write in the form of fraction. Then it will be in P by Q form. 7 by 5 fraction P by Q form there. 3 by 2 P by Q. And coming to minus 2. Minus 2, I don't have a denominator, you feel. But look here, minus 2, I can say it as minus 2 by 1. So any number like this, you can think that 2 by 1 might be 3 by 1. These numbers are also expressed in the form of P by Q, where P you can see, Q you can't see. That means these are all the numbers which are divided by 1. Here, let me take one more round. What is a letter used to represent rational numbers? Q, right? In rational number, natural numbers will be there, whole numbers will be there, integers will be there. What are the numbers which are extra? Fractions and decimals. 0.7, 7.25, 8 by 3. These are all called as the rational numbers. So, big circle you see. In rational numbers, all the other numbers are subsets. This can be written as natural numbers are subsets of whole numbers, subsets of integers are subsets of rational numbers. Only rational numbers are there? No, we have one more type of numbers. Those are called as irrational numbers. Irrational numbers are represented by the letter Q bar. Irrational. What are irrational numbers? We know rational numbers, the numbers which can be expressed in P by Q form are called as rational numbers. Here, which cannot be expressed in the form of P by Q are called as irrational numbers. Example you can take as pi is an irrational, and root 2, root 3, root 5, so on are all irrational numbers. Rational numbers and irrational numbers combinedly called as real numbers. combinedly called as real numbers. See, in real numbers, these are all subsets. Rational numbers and irrational numbers combinedly called as real numbers. Let's have a quick recap. Natural numbers, all the counting numbers are called as natural numbers, denoted by the letter capital N. Natural numbers along with 0 are called as whole numbers, represented by the letter capital W. Whole numbers along with the negative numbers are called as integers, and it is denoted by the letter capital Z. Integers along with fractions and decimals, we call them as a rational numbers, or rational numbers, the numbers which can be expressed in the form of P by Q, where Q cannot be equal to 0. Irrational, the numbers which cannot be expressed in the form of P by Q are called as irrational numbers. Combinedly, rational and irrational numbers are called as real numbers. This year we are going to deal with rational numbers, and in this rational numbers, first topic is properties. I think we already have done these properties in our previous classes. In this chapter, first topic is properties like closure property, commutative property, associative property, distributive laws. These are all we have seen. In our previous classes, we have applied these properties for natural numbers, whole numbers and integers. Now in this year, we are going to have a recap of all the numbers along with rational numbers. Now we are going to deal all the properties along with the operations one by one with all the numbers. Like, let us start first property, closure property, with all the 4 operations like addition, subtraction, multiplication and division for natural numbers, whole numbers, integers and rational numbers. After completing one property, we are going to discuss another property. We are going to start with the properties. First property, closure property. So natural numbers, whole numbers, integers, rational numbers with all the 4 operations: addition, subtraction, multiplication and division. Okay. So what is closure property? Immediately you remember. What is the property you need to remember? See here. A, B. Let A and B be any 2 numbers. Suppose if I talk here natural numbers, A and B must be natural. Whole numbers, A and B must be whole. Integers, A and B must be integers. And rational, A and B must be rational numbers. Closure property. What is the property you remember? Immediately, A, B is equal to C. When you talk about a number, that numbers you need to think. Natural, A and B be natural numbers. Addition, we are doing the operation addition. So, sum of the 2 natural numbers must be natural number. Then the property is satisfied. Next, whole, same manner, A and B must be whole numbers. Sum of the 2 whole numbers, result must be whole number. If integers, sum of the integers should be integer. Rational, sum of the rational numbers must be rational number. Then only closure property is satisfied. Same manner for all the 3 operations. See here, this equal to. We don't know whether it satisfies or not, but I am taking here equal to in order to check these all numbers. Right? A plus B is equal to C is a closure property under addition. So under subtraction, in the place of plus, you take minus. A minus B must be equal to C to satisfy the closure property. Multiplication, A into B equal to C. Division, A divided by B equal to C. Okay. So let me start with the first numbers, natural numbers, by taking A and B value. Okay. Let us take any 2 natural numbers. Okay, let me write here. A is equal to 3, B is equal to 5. Same A and B value I am going going to take for all the 4 operations. In A place substitute 3 and B place substitute 5. 3 plus 5. 3 plus 5 it is 8. If 3 and 5 are two natural numbers, sum of these two natural numbers result is also a natural number. So what you can say? Yes, it is closed under addition. Closure property is satisfied for natural numbers under addition. Next, under subtraction, same A and B value. Substitute in this 3 minus 5. What is 3 minus 5? It will be minus 2. The result, is it a natural number? No, it is not a natural number. So what you can say? No, minus 2 is not a natural number. Therefore, what you can say? No, it is not satisfied. And here you can say it as yes, it satisfies, and here no, it does not satisfy this condition for natural numbers. Next, closure property of natural numbers under multiplication. Same A and B value, substitute in this 3 into 5. 3 5s are 15. Two natural numbers, if you multiply, the result is also a natural number. Therefore, closure property is true for natural numbers under multiplication. Next, division. 3 divided by 5 is equal to, see here, 3 divided by 5, I can write like this. 3 by 5, if you divide, you are going to get in decimal. Decimal, is it a natural number? No. Therefore, this is not a natural number. Not a natural number. Therefore, what you can say? No, closure property of natural numbers under division is not satisfied. Closure property in natural numbers satisfies only addition and multiplication. Okay, so next type of numbers, whole numbers. Take any two whole numbers. Let A is equal to 2 and B is equal to 7. A is equal to 2 and B is equal to 7. Same properties. Whole numbers, closure property under addition. Substitute in this. If you want, you can draw a line here. Now, substitute in this A and B value. 2 plus 7 is equal to 9. These two are whole numbers. Sum of the two whole numbers, the result is also a whole number. Yes. Therefore, what you can say? Yes. Closure property of whole numbers under addition is satisfied. Next, subtraction. Same manner, substitute. 2 minus 7 is equal to. 2 minus 7 will be minus 5. So, this is not a whole number. Minus 5, is it a whole number? No, it is a integer. Therefore, minus 5 is not a whole number. What you can say? Closure property is not true for whole numbers under subtraction. Next, multiplication. 2 into 7 is equal to. 2 7s are 14. Yes, the result is also a whole number. Therefore, the closure property is true under multiplication of whole numbers. Next, division. 2 divided by 7. 2 by 7. Again, it is a fraction. Fraction does not come under whole numbers. Therefore, directly I can say no. Therefore, closure property of whole numbers is not true for division. And in this whole number, closure property of whole numbers is true only for addition and multiplication. Next, integers. Integers. Let us take A and B value. Any two integers you take. Let me take A is equal to minus 3 and B is equal to 2. Closure property of integers under addition. So what it is? Substitute in this. Minus 3 plus 2 is equal to. Minus 3 plus 2 will be minus 1. We are talking here about integers. A and B be any two integers. The result is also an integer. Therefore, yes, this property is true for addition. Next, subtraction. Same A and B value I am going to take minus 3 and 2. Substitute in this. Minus 3 minus 2 is equal to. Minus 3 minus 2 will be minus 5. How? If both are negative, take the negative sign and add the numbers. Minus 3 minus 2 is minus 5. Is it an integer? Yes, it is an integer. Right? Next, multiplication. Minus 3 into 2 is equal to. Here nothing there, that means plus you have. Minus into plus, minus. 3 2s are 6. Minus 6 is also an integer. Therefore, this property satisfies under multiplication. Next, move to division. Division. Substitute in this. Minus 3 divided by 2, that is minus 3 by 2. See here again it looks like a fraction. Fraction does not belongs to integers. Therefore, closure property of integers does not hold good for division. Closure property of integers is true for addition, subtraction and multiplication. Next type of numbers is rational numbers. Let me take A and B value. A is equal to 1 by 2 and B is equal to 3 by 5. 1 by 2, 3 by 5. What is closure property under addition? A plus B is equal to C. Substitute A and B value. A value is 1 by 2. B value is 3 by 5. I think every one of you know the fraction operations, right? If you don't know, you can check the video of Mathematics Basics. Fraction operations, you have one video. Right? Now this LCM we need to do. 2 5s are 10 is the LCM. Okay? And in 2 table where you get 10, 5. Multiply for the numerator. And in 5 table where you get 10, 5 2s. Multiply here 2. 1 into 5, 5. What is the sign? Plus 3 2s are 6. 5 plus 6, 11. 11 by 10. 11 by 10. See here. Rational numbers. Closure property. Sum is also a rational number. So finally what we say? Closure property of rational numbers is true for addition. Yes. Yes, it is true. Next operation is subtraction. A value 1 by 2, B value 3 by 5. 1 by 2 minus 3 by 5. Okay. Again do the LCM. 10. 2 table you get 2 5s are 10. 5 multiply here. 5 table you get 5 2s are. So multiply 2 here. 1 5s are 5. Minus 3 2s are 6. Minus 1 by 10. Minus 1 by 10, is it a rational number? Yes, it is a rational number. Therefore, closure property of rational numbers is true for subtraction. That means you write here yes. Next, multiplication. Write the A value and B value. 1 by 2 into 3 by 5 is equal to. Multiply numerators by multiply denominators. 1 into 3, 3. 2 5s are 10. 3 by 10. Again it is a rational number. The two rational numbers, if you multiply, the result is also a rational number. Closure property holds good for rational numbers under multiplication. So what we write? Yes, it is true. Next, closure property of rational numbers under division. So 1 by 2 divided by 3 by 5. How can you rewrite this one? Is equal to 1 by 2 divided by, whole divided by 3 by 5. This 3 by 5 bring to the numerator. How? We need to do the reciprocal of the denominator and then multiply to the numerator. Once again, do the reciprocal of the denominator and multiply to the numerator. Reciprocal of the denominator means 5 by 3. 1 by 2 into reciprocal of the denominator means 3 by 5 you have. Reciprocal 5 by 3. 5 into 1, 5. 3 into 2, 6. Yes, 5 by 6 is a rational number, right? Closure property of rational numbers under division, is it satisfied? Yes, by this example it is satisfied. But it should satisfy any type of numbers of rational numbers. But here it does not satisfy for one condition. What is that condition? So here, if any number, suppose if 1 by 2 is divided by 0, it is not defined. Suppose if we take one of the rational number is 0, this condition is not satisfied. Therefore, we say no for this. Out of 100 marks, if you score 99, you are not the topper, right? Yes, if you want to be topper, you should score 100 marks. Here also, if you are able to satisfy any type of numbers, then only this condition is true. If any one pair of numbers is not satisfied, then this condition is no. Okay? Closure property of rational numbers under division may not satisfy all the type of numbers. Closure property of rational numbers may be satisfying all types of numbers. At one condition it is failed. So therefore finally we say that no. Closure property of rational numbers is true for addition, subtraction and multiplication only. Closure property, sum of any operation, the result must be the same type of number. So that is what you need to remember. A plus B is equal to C for addition. Closure property of natural numbers satisfies addition and multiplication. Closure property of whole numbers satisfies addition and multiplication. Closure property of integers satisfies addition, subtraction and multiplication. Closure property of rational numbers satisfies addition, subtraction and multiplication. Yes, in our next session we are going to meet with another property. Until that, keep watching. Thank you all.